Hello, don't forget to subscribe. Don't forget to subscribe. Okay? I want to talk to you about the octet rule and how it relates to molecules. The octet rule is the tendency for atoms to bond in such a way that each atom has 8 electrons in its valence shell, giving it the same electronic configuration as a noble gas. A molecule is a covalently bonded pair or group of atoms that are electrically neutral and maintain the properties as its substance. Water and ethanol are examples. But I'm going to focus today on water. It's held together by covalent bonds. It has 2 hydrogen atoms and 1 oxygen atom that's covalently bonded. That means they're sharing electrons. Now, when we look at this, we have oxygen, and oxygen has 6 valence electrons, so we put 6 dots on its dot diagram. It's in group 16. 3, 4, 5, 6. It's in group 16, so that's why we got 6 dots. And you see it over there. It wants to actually be like neon. It wants to be like neon. It wants to fulfill its octet rule and become like neon, because that's its noble gas. That's its nearest noble gas. Now hydrogen's in group 1. It's in group 1, so it wants to be like helium. So it has 1 valence electron, but it really wants to pursue a stability like helium, which has 2. So it's going to do that by sharing electrons with oxygen, just like that. Always associate covalent with sharing electrons. Here's hydrogen. It's going to come over here and share electrons, and now it has 2, just like helium. So it's fulfilled. Everybody's fulfilled. Oxygen's fulfilled. Hydrogen's fulfilled. It's H2O. Oxygen wants to have 8 valence electrons, just like neon, which is right over there. 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. It's happy. It's stability. That's what it's seeking. Stability. So 2 dots can be represented by a dash between the atoms. The dash is a single covalent bond. So whenever you see that line between the 2 atoms, that's what it means. It's a bond, covalent bond. So we can take 2 dots and put a dash there instead, put a line there instead. That'll be a single covalent bond. We can take the other 2 dots, make another single covalent bond, replace it with a line or a dash. Okay, that's what we call a single covalent bond. And the other dots up there on top of the oxygen, there's no atoms to connect it to. We can also write it this way, with just this bent structure, this Lewis structure. Sometimes you don't see the lone pairs, but I'm going to draw the dots here. We call them lone pairs because they're not bonded to another atom. A bond is between 2 atoms. Those dots are just stuck there on top of oxygen, okay, without being bonded to a second atom.